Hey guys, chapter 9, review number 3. A rocket is launched off of a platform such that its height in feet is determined by the function h of t, where t is time in seconds. Part A, when will the rocket hit the ground? Well, if the rocket is hitting the ground, that means the height must be 0. So we want to know, when will h of t be 0? So this is a quadratic function. How do I solve a quadratic function? I can either factor it or use the quadratic formula, but this one factors fairly easily. Negative 16t can be factored out of both terms. So let's factor out our negative 16t. I'm left with t minus 5. Doing zero product property, I get negative 16t equals 0, so t is 0. And t minus 5 equals 0, so t equals 5. So the rocket will leave the ground when time is 0, but when will it hit the ground again? After 5 seconds. After 5 seconds, it returns to the ground. Okay, let's take a look at part B. What is the velocity of the rocket after 1 second, after 2 seconds, after 2.5 seconds, 3 seconds, and 4 seconds? Well, in order to find the velocity, remember that our instantaneous rate of change is going to be the velocity at each particular time. So in other words, I want to find IROC for my function, and then I can evaluate it. So we are going to do f of t plus h minus f of t all over t plus h minus t. And in order, when we're doing IROC, remember that we are going to find the limit of this as h approaches 0. So I'm kind of combining our steps. So we're first going to do AROC, which is just this piece, and then we will find the limit. So, come back here. Okay, let me scoot that up. Working through AROC, we need to find f of t and f of t plus h. So f of t is going to be, f of t is negative 16t squared plus 80t. F of t plus h, negative 16 times the quantity t plus h squared plus 80 times t plus h. Okay, so we need to expand that. We're going to get negative 16 times t squared plus 2th plus h squared. We'll have to distribute our negative 16. I'm also going to distribute my 80. So plus 80t plus 80h. Okay, let's distribute our negative 16. We get negative 16t squared minus 32th minus 16h squared plus 80t plus 80h. And just looking through there, we do not have any like terms, so let's jump right into our AROC. Excuse me. Okay, so we're going to find our f of t plus h, which is that long expression we just ended with, is going to be, let's go to green, negative 16t squared minus 32th minus 16h squared plus 80t plus 80h minus my f of t, which is negative 16t squared plus 80t. And this is all over h. Okay, working down into the C section. I'm going to distribute my negative, so add the opposite. Notice that we've got some terms that will wipe each other out. Negative 80t plus 80t is 0t. We also have 16t squared and a negative 16t squared. So we are left with negative 32 th minus 16 h squared plus 80h all over h. Notice that we have an h in every term, so we are going to factor out an h, and we'll have negative 32t minus 16h plus 80 all over h, getting our h over h to be our giant 1, and we finally have our A rock. We're going to take that and find the limit as h approaches 0 of negative 32t minus 16 times 0 plus 80. So guys, we are down to a simplified expression of negative 32t plus 80. So this is our instantaneous rate of change. And now we can evaluate after 1 second. So we're going to stick 1 in. Let's just go up here. We're going to evaluate negative 32 t plus 80, and we're going to plug in each value. So plugging in 1, we have negative 32 plus 80, which gets us 48 feet per second. Let me scoot this over here. Feet per second, okay. Then plugging in 2, and so on. So negative 32 times 2 is a negative 64 plus 80 is 16 feet per second. Plugging in 2.5, we end up with 0 feet per second. Plugging in 3 seconds, we're going to get negative 16. And plugging in 4 seconds, we get negative 48 feet per second. So we can see the path of this rocket. Let's go down and look at what part C is asking us to do. It says, what do the values, what do the velocity values from part B indicate about the path of the rocket? So as you can see, the rocket is increasing in height. It's going up, going up, going up. It reaches a max height after 2.5 seconds. So here it's reached its peak, and then it starts to decrease in my velocity. And so that means that it's going to decrease in our height. In other words, it's going to fall. Okay, and you can write that up. Let's go down to part D. Part D says, at what time is the rocket at its maximum height? Well, as we just said, the maximum height happens 2.5 seconds after it has been launched. And how do we know that? Well, because the velocity at that time is 0. So if you think about it, if I have my curve, and I know we said that this was a quadratic, we know that it opens down because it's a negative 16t. So as I'm looking for my instantaneous rate of change. So this is after 1 second, come on, 2 seconds. After 2.5 seconds, my instantaneous rate of change, my IROC, is 0. That means that my slope is 0. When I have a 0 slope, when my slope is 0, I know that I have a horizontal line. Okay, so that's how we know that it's hit its peak and now it's heading back down. Okay, and the last part, what is the speed of the rocket right before it hits the ground? Oh, if you remember in our toolkit, we talked about the difference between velocity and speed, and the major difference between velocity and speed is that velocity can be negative, which indicates direction, but speed is the absolute value of our velocity. Okay, so let's also recall that back in part A, we found that it's going to hit the ground after 5 seconds. So from part A, it's going to hit the ground after 5 seconds. Okay, so let's find the, like we did for part B, what is its velocity after 5 seconds? We found up to 4 seconds, so let's go ahead and find after 5 seconds. So it's going to be our negative 32 times 5 plus 80. Okay, negative 32 times 5 is negative 160. Negative 160 plus 80. Okay, why are my numbers not showing up? There we go. Is negative 80. And we are looking for the speed, which is going to be the absolute value of our velocity. In other words, it's going to be 80 feet per second. Guys, this is an excellent question because it involves everything that we've studied this chapter, and it's definitely very fair game for a test question. All right, have a great day.